All right, we're back for
Yes.
chemistry.
We're back.
Yes, it's Miss Gray and Mrs. Uy.
Mrs. Uy back.
So now we're finally on Unit 2.
Yes.
Yes, scientific measurement.
Scientific measurement. And today we're going to talk about scientific notation.
Right.
That's our podcast 2.1, scientific notation, guys.
Yep. Some of the numbers you're going to see in science are really big,
Oh,
and some are really small.
Mm-hmm.
So we're going to talk about using measurements when you have very large numbers or very small numbers.
Very small numbers.
And here's an example that our students are going to get pretty familiar with. In 2 grams of hydrogen, which is this stuff right here,
Yes,
H2,
H2.
there are this many hydrogen atoms.
I don't even know how to read that, Miss Gray.
No, me neither.
No.
Here's million.
There's
million.
a lot of
Yeah.
zeros in that number.
There are a lot of zeros in that number. So
Yes.
we're going to use scientific notation.
Yes.
And it's pretty simple. We're going to write numbers in exponential form
Mm-hmm.
that's based on
Powers of 10.
powers of 10.
Yes.
Bravo. And here's how that works. It's so slick. How many zeros do you see here?
1.
So 10 is really 10 to the first power
All right.
because there's only one 10 there.
Mm-hmm.
But if I have 10 times 10,
You have 2 zeros.
that equals 100.
Mhm.
And that's 2 zeros. And so we call this 10 to the second power. And if there's 3 zeros, that means 10 times 10 times 10, 10 to the third. And we could keep going. Look, 10 to the fourth.
Mm-hmm.
And let's do another one. 10 to the fifth. Just counting up zeros here. 1, 2, 3. What if there's not zeros there? What if there are other digits? Doesn't matter. It's in
Yeah.
the 10,000 place.
Yes.
So it's still times 10,
10
to the 4. And that's how we do scientific notation.
Scientific notation.
We are basically dividing the number by powers of 10 and writing down the decimal we
Yes.
get.
Makes life easy.
Definitely. Because I can add or I can multiply and divide any number by 10 in
Yeah.
my head
Yes.
easily.
Mm-hmm.
All right, well, let's do the number we had before. We had Avogadro's number. So
Oh, Miss Gray is writing it.
602.
Let's see if she can make it. More zeros. See, Miss Gray, that's really tiring. I bet our students don't like to do that. So they should be very grateful that we have this scientific notation in chemistry.
You're interrupting my thoughts.
Are you still okay,
3 more.
Miss Gray?
Okay. I think so. There should be 23 spaces after my 6. 1, 2.
Mm-hmm.
Okay, why don't you tell us what to do with this while I count?
Yes.
Oh, 3 extra zeros. You distracted me.
Yes. Sorry, Miss Gray.
It's all your fault. At least that's my story. And
Yeah.
I'm sticking to it.
Mm-hmm.
All right. So I counted after my 6, 23 spaces after the 6.
Okay.
All right. Let's keep that in mind.
Mm-hmm.
What we need to do is have only one digit in front of the decimal. That's all we're allowed. That's
Okay.
why I was looking after the 6.
Mm-hmm.
I only have to have
1.
1. I'm only allowed to have 1.
Okay.
Okay.
That's the first rule in scientific notation, or that's one of the rules?
That's the rule.
That's
the
the
first one,
rule.
right?
Okay.
After this
Right. 10
numbers,
times?
we're going to write
Times 10.
times 10.
Times
So
10.
I'm going to put 6.02. Now all I have left is zeros. So I'm going to
Yes.
put times 10. Okay. So now, count the number of decimal places you moved.
Mm-hmm.
And I just told you, I
Yes.
counted 23 spaces.
23.
Boy, that counting took a long time.
Oh, yeah. Plus, I distracted you, so.
Yes, it made me mess up. And we're going to write that number as a superscript. Remember,
Yes.
Superman flies up high in the air,
Mm.
right? So the superscript goes up high.
Goes up.
A submarine goes down below.
Goes down below.
Submarine. So a subscript
Subscript.
is down low, like in H2.
Makes sense.
Right. So we want a
Superman and
superscript.
submarine.
Right,
Okay.
exactly. And then we look at which way we move the decimal.
Mm-hmm.
If we moved it to the left, then our superscript is going to be positive.
Okay.
So our decimal started back here at the end of our number.
Right.
And we had to move it to
To
get
the-
it here after the 6, we had to move it to the left.
Yes.
This means we have a really big number,
Oh, yes.
right? But if you're moving to the left, that means you have a large
number.
Right. And if you move your decimal place to the right, you have to get a negative superscript.
Mm-hmm.
put a minus sign in front of it
Okay.
because that indicates a small number.
A small number.
Right reduces.
Left, large,
Mm-hmm.
starts with an L.
Right.
Right, reduce, starts with an R.
Exactly.
All right?
Hopefully that's easy to keep track of.
Yeah.
But let's practice.
Okay.
All right. We'll show them how it's done.
Mm-hmm.
Okay. In any whole number, we have a decimal that's implied
Yeah.
at the end.
At the end.
Okay. How many places do I get in front of my decimal?
Let's start counting, Ms. Gray.
1,
2, 3,
3,
4, 5, 6, 7.
All right. So that's where I stop. I don't keep going because I have to have 1 in front, but I'm only allowed 1
Yes.
in front. I can't put the 3 and the 4 there too.
Yes.
And we moved it 7 times. Did we go left or right?
Left.
Okay. So we
it's
get
a
a
positive
positive
number.
7. Right. That implies a big number.
Yes.
Okay. That's how we did number 1.
Mm-hmm.
Now, my decimal place has to go here. I only get to keep 1 digit
Yes.
in front. So let's move. 1,
2, 3, 4. And we're moving to the right, so
Mhm.
it's negative.
Correct.
Superscript.
So don't forget to put a times 10,
Mm-hmm.
and we went 4 spaces.
Yes.
All right, so please don't write it like this. That means something different.
Mm-hmm.
That means you have 1 over 7.24 raised to the 4th power. Okay, so don't write it
That's
without
wrong.
the times 10.
Yes. Because we're talking about scientific notation.
Right, right.
Yes.
That's 2 different kinds of operations.
Yes.
Good. We'll show them how to use their calculators for this
Mm-hmm.
in our next podcast.
Yes.
Okay, now I already have scientific notation.
Okay.
We have to go backwards this time.
All right.
Okay, and since we're going backwards, our rules are backwards. Okay, to have a negative, we said right reduces.
Yeah.
Well, to get a small number, I have to move my decimal to the left. Okay.
Okay.
And we're going to move it 8 times.
8 times.
1, 2, 3, 4, 5, 6, 7, 8. I'm running
It
out of
looks like
space.
waves, Ms. Gray.
I know. What do I do with my waves?
Okay.
Because I got to fill in these spaces
With
here.
zeros.
Yeah, that means
How many zeros? Like
It's a
1, 2,
really
3,
tiny.
4, 5.
all of those little bumps.
7
Yes, 7. Because the 8th space
is
was
5.
for the 5. All right.
So
So
to write that,
I'm going to put a decimal and my 7 zeros. I lost count already. 5903.
3.
Keep all the digits they give you.
Yes.
Just, write them afterwards. And I like to put a 0 in front of my decimal place as a signifier that, hey, look, there's a decimal coming up.
yes.
You don't have to. It's the same number with or
Yeah.
without it, but it's a good signal to somebody that
Yeah.
there must be a decimal there,
Okay.
right? Okay, let's do
Oh, that one is
the
not
opposite.
hard.
This must be a large number
Mhm.
because it's a positive 3.
Okay.
Okay, so instead of going left,
We're going to the right.
1, 2, 3, and I have more waves. Any empty waves,
Yeah.
put a 0 in. 6, 2, 0, and one more 0. And we have 6.20 times 10 to the third
To the third.
is the same as 6,200.
Yes.
And that should make sense because what we're saying is 6.20 is multiplied by 10 to the third power. 10 to the third power is 1,000.
Oh, yeah.
Okay, so
that's
multiply them together.
6,200.
Yes,
Mhm.
right. So scientific notation is a shorthand way of writing big numbers
And small
and
numbers.
small numbers.
Yes.
We will be using both in this class.
Exactly.
All right, well now let's do some calculations. Sometimes students get confused about these rules,
Yeah.
but let's make sure that we know what to do.
Okay, that means using scientific number in addition.
Yes.
Okay.
So in addition, our exponents must be the same or we can't add them together.
Yes.
Okay.
That's the rule in addition.
So here's an example where I have 10 to the third and 10 to the second.
Mm-hmm.
And just to be clear, I'm going to write these out in decimal form. 1030 is 10 to the third.
Mm-hmm.
Okay. And 210 is 2.10 times 10 to the
yes.
second. Right?
Mm-hmm.
So if I'm adding these two numbers together, I cannot just put 1.03 plus 2.10
Yeah.
because that's not what I'm adding together.
Yes.
So this wouldn't be correct.
Mm.
It says change the exponents so they match. Here's how we do that. We take our larger one and make it smaller. We're going to reduce it.
Reduce
How do
it
we
to
move our
2.
decimal to make it smaller? Right reduces, move it over one time so we can change
To 2.
to a 2. And so then we get 10.3 times 10 to the second plus 2.10 times 10 to the second.
Now the exponents are the same.
Right. Now I could have moved this one instead and made this larger, and I just always pick the biggest one and make it smaller.
Okay.
Always go to the smallest.
Okay.
It just seems easier. Okay, so now add 10.3 and 2.1. So then we're going to add our coefficients.
I'm going to use my calculator in that, Miss Grace. Okay,
you can check my work. I'm just going to add, I get 12.40.
Yes.
Okay, good. And our exponent is still 10 to the second. We made them both the same. But now we have to
copy the same exponent.
Yes. Now we have to check our answer, though. Remember, the rule says we can only have one digit in front of the decimal. Okay, so I'm going to move to the left. What does that do to my exponent?
It will make your exponent big.
Left makes larger.
Larger.
Yes.
So that becomes 3.
Right. Okay.
So the final answer is 1.24 times 10 to the power of 3.
Right. And when you get an answer, I want my students to put a box around it, because that's the way I like it.
I need to remind my students about that, because sometimes,
it's easier to find. Now let's check our answer. Hey,
there you go.
1.2.
Got it correctly, Miss Gray.
Thanks.
Clap for Miss Gray.
Oh, I know. Thanks to Miss Uli's support. What's going on?
There you
Subtraction.
go.
Yay.
Subtraction.
All right. Again, like addition, change the exponents so they match.
Okay.
Right? Because addition is the same thing as subtraction, only we're adding the inverse. Right? So
we're going to start with 3.
Oh, yep, make them the same. So to reduce it, we move to the right.
Yes.
So
So
move
that
it over.
becomes 10.3
10.3 times 10.
to the power of 2
All right.
minus 2.10. I'm going to check that.
Okay, and I'm going to do the subtraction.
All right.
10.3 minus 2.10, which the 0 isn't really important. 3 minus 1 is 2, and then 10 minus 2 is 8. Did you get 8.2?
Yes, 8.2. You're correct, Ms. Gray.
All right.
And times 10.
And we're still at times 10 to the second. Now let's look at our answer and see if this is a proper scientific notation.
Yes.
We're only allowed to have one digit in front of our decimal, and we're okay there.
Yes.
So we can go ahead and put a box around
Box in our number.
and check the answer. Hey!
Yay!
2 in a
2
row.
points for Miss Gray.
That's right. We're good. Now let's look at an easier rule.
Okay.
If we're going to multiply numbers, all we have to do is add the exponents together.
That's easy.
Yeah. So
Very
here's
easy.
our same numbers again. We worked with these in the last 2 problems.
Yes.
So we take our coefficients and multiply them together.
And I'm going to multiply them now.
Okay. And so we could do this kind of multiplication, but I'm going to let you tell me what it is.
It's 2.163.
2.163. Great. And now let's add the exponents. So it's 10 to the 3 plus 2. So I get 2.163 times 10 to the 5th power.
Yes, 3 plus 2 is 5.
And that's it. Now, in our question, we had 3 decimal places, or 3 digits, I should say.
Yeah.
So 1, 2, 3 digits is all we get to keep.
Okay.
Okay. We'll go over those rules later.
Oh, yeah.
Sig figs.
Another thing to remember, sig fig.
Let's check our answer. 2.16 times 10 to the 5.
3 points.
Wow, it's like we've done this before. What?
Division.
Division.
Yes.
Okay. So now it's very similar to the multiplication rule. When we multiplied, we added the exponents.
Multiply, add, divide, subtract.
The exponents.
Easy to remember.
All right, so we take our coefficients, 1.03,
and then we divide
and
it.
we're dividing. Divide by 2.10. Right, so in your calculator, if you do this, you're going to push in 1.03 first, and then that divide button.
Yeah.
Right, and then 2.10.
Okay, let me try that again.
Yeah.
Divided by 2. It's 0.490.
49. All right then. And let's subtract our exponents. It's 10 to the 3
3
minus
minus
2.
2.
All right, and that's equal to 1.
Mm-hmm.
So we get 0.490 times 10 to the first power.
Mm-hmm.
But we're breaking our rule. This is not proper scientific notation.
Yes.
Because I need a non-zero digit in front of my decimal.
Oh, yes.
Okay, so I'm going to move to the right. And if
That makes our exponent large.
No, right reduces.
Oh, right reduces. Oh, yeah.
Okay.
Our right reduces, sorry.
And so we went down by 1
Mm-hmm.
to 0.
Mm-hmm.
Well, what's 10 to the 0 power? It's just 1.
It's just
Because there's no zeros left.
Yeah.
0 zeros.
Mm-hmm. Zero
So-
zeros.
10 to the 0 power is the number 1.
Mm-hmm.
That means 4.90
4.90.
times 1 is equal to 4.90.
Yeah.
And so that's the answer that goes in our box.
Okay.
That's how we divide. Let's check our answer.
There you go.
We're good.
4 points for Miss Gray.
Yep, 4 in a row.
Yay.
Yes. And
That's
we'll
easy, Miss Gray.
we'll have lots of practice at this.
Yeah.
But when you do your worksheet, it's okay to bring this podcast back up
Mm-hmm.
and look at, well, now I'm on a addition problem.
Addition.
How do I add? So go ahead and use your podcast while you're doing the worksheet if you want. All right. We'll
Always
see you.
pause and rewind.
Pause and rewind.
Yes, if you need to.
Yep. See you guys in class.
Yes. Enjoy.